This lesson is going to be covering using complex numbers. Before we get started adding, subtracting, multiplying, and dividing complex numbers, we should probably have a look at what a complex number is and kind of where they came from. So first of all, when we start talking about complex numbers, we're referring to the imaginary number I. So a complex number is this imaginary number I, and it's basically equal to the square root of -1. Now before, when we were working problems, we would run into trouble if we had something like the square root of a -16. We would say no real solution or no real answer. That was because if I had to find the square root of a -16, somehow I had to be able to talk about this negative sign and pulling it out front, square root of a -1 times the square root of 16, then I could work with this. So the square root of 16 we know is 4. And then this, I couldn't deal with this. This is not a real number. It's called a complex number, so that's why we're in a new number system. The square root of -1 is I, so I get 4i here then for the square root of a -16. So that's where the complex number comes into play. Now there's a few that we'll want to have memorized here besides I equal the square root of -1. We also want to know what I squared, I cubed, and I to the 4th is. And if we have these four memorized, we'll be able to work most problems pretty easily. I'll also show you how to use your calculators here to check your work. Now I squared is basically the square root of a -1 times the square root of -1, which is going to be just the radicand back, -1. I cubed would be something like I squared times I, because remember when you multiply like bases you add the exponents. 2 plus 1 is 3. Well, I squared is a -1. I to the first is just I, so here I'd get -I. So I is just I squared is -1, I cubed is -I. Now I to the 4th, we could look at this as I squared times I squared, which is -1 times -1, which is 1. So these four you definitely want to have memorized. They come in handy when you're working problems. Now you might say, well, why don't I have to memorize I to the 5th? Well, there's an interesting pattern here that occurs. I to the 5th, I just start repeating this entire sequence again. I to the 5th is I to the 4th times I to the 1st. But we know from here I to the 4th is equal to 1. I to the 1st is just I. So I just start over again at I. And this is going to be true with I to the 6th, I to the 7th, I to the 8th. What if we were throwing something like I to the 31st? How would we do that? Well, the key to these types of problems is to realize this I to the 4th is 1. So if we can pull out all the I to the 4ths that are possible, that's really going to make my problem easier. So what I want to think about here is, what is the largest multiple of 4 that's less than 31? And that would be 7 times 4 is 28. So this would be I to the 28th, I cubed. Now I to the 28th is I to the 4th to the 7th, because remember when you raise a power to a power you multiply the powers. Now this piece right here, I to the 4th, we know is just equal to 1 from what I have memorized. So I have 1 to the 7th times I cubed, and of course 1 to the 7th is 1, and I cubed we know from up here is -I, so I just get -I back. So I to the 31st is just -I. Now I can do this with any power of I. I look for the highest 4th power I can pull out, and then whatever the remainder is, basically, in this case 3, I go back to my list over here and I compare it to my list of 4 things that I have memorized. I is I squared is -1, I cubed is -I, and I to the 4th is 1. And whatever the remainder is, I just pull that out as my solution. Now also when we're working with complex numbers, we have something called standard form. So in my math lab, and when you're working on your exam, when it says standard form, they mean put it in a plus bi form. So a is called our real part. It's not a complex number, it's our real number, like 2. And then bi is our complex. So I could have something like 2 plus 3i. This is in standard form. Real comes first, complex comes second. Now if I just had a complex part, let's say we had no real part and a complex part, usually I would just write that as a minus 2i. You don't include the 0. So all of your answers are supposed to be in a plus bi form when you're working here. Now to get started, let's go ahead and look at adding and subtracting complex numbers. And this is actually pretty easy because all we really do is combine like terms, and we're pretty good at that. We add the reals to the reals and the complex to the complex. So let's look at an example to get started here. Let's look at 7 minus 7i plus the quantity 1 plus 4i. Now the parentheses here are just grouping symbols. Distributing the plus sign would have no effect here. So really if I wanted to, I could just drop the parentheses. And I notice that I have 7 and 1 as my real components. And then over here, my complex components are minus 7i and a plus 4i. So then I just add my reals to my reals. 7 plus 1 is 8. And I add my complex to my complex. Negative 7i plus 4i is a negative 3i. And so that is how this simplifies, 8 minus 3i. Now sometimes you'll have a little bit more work to do. For instance, we could have a problem where I actually have to do some distribution. My negative sign out front of the parentheses, I can't just drop the parentheses, I actually have to distribute. So I take this negative sign and I would distribute into the parentheses after it. So I'd have 8i minus 9 minus a negative 6i is the same as a positive 6i. And then we do the same thing again. Negative 9 is my only real number here. My complex numbers are 8i plus 6i. 8 plus 6 is plus 14i. So adding and subtracting complex numbers isn't too bad. Now let's go ahead and look at how we would do one of these with a calculator, because you do have an I key on your calculator. Your I key is right down here under, right above the decimal. Okay, so it's right here, the I. So let's look at our first one. If you want to put in the parentheses, you could do 7 minus, remember don't use your negative key, use your minus key, 7i. Now to get to that blue I, we have to hit second and then the decimal to get the blue I. And of course I'm just going to leave my parentheses up here. And then 1 plus 4, same thing again, second with the I key. And what happens is this puts our answer in standard form, so I have 8 minus 3i. So if I remember right, let me see here, we did get 8 minus 3i for our first answer. So here is my 8 minus 3i. So again, use your calculator to check your work, to double check everything that you're working on is correct. Now sometimes if you get really high powers of I, the calculator might run into some problems, but for the most part you should be able to check your answers. Let's go ahead and look at multiplying now, multiplying complex numbers. Now sometime when you're multiplying complex numbers, you'll have monomial times a monomial. Sometimes you'll have a monomial times a binomial. But the thing to remember is nothing changes in the process. It only changes at the end when we're combining our i's. So for instance, we could have a monomial, a single term, times a binomial, 7 minus 6i in this case. And the process is the same. You take the 8i, not just the I, but the 8i, and distribute it to everything in the parentheses after it. So I'll have 8i times 7 plus 8i times a negative 6i. So 7 times 8 is 56i. Now over here, negative 6 times 8 is a negative 48i squared. Now, remember, our standard form is a plus bi. Nowhere in our standard form does it say I can have an I squared. Well, we just need to remember from our first page that I squared equals negative 1. That's why it's so important to have those first 4 memorized. So I squared is equal to negative 1. 56i, negative 48, I squared is that negative 1. And of course a negative times a negative is a positive. It's still not quite done. Remember, a plus bi, it's real plus complex. This is in the exact opposite order of what I need. So I need 48 plus 56i. There's my solution. So when we're working these types of problems, I just need to remember you have to simplify it and put it in standard form, but the process of distributing is no different than it always has been. Okay, let's go ahead and look at an example where we're multiplying again, but for this one, we're multiplying a binomial times a binomial. So here, we could use the FOIL method, first outside, insides, lasts. We could use the box method, whichever method you're best with, that's what you'd want to use here. I'm going to look at the FOIL method. So I have a -2 times a -2. And then my outsides, -2 times a -I. My insides, -2 times a +I. And then of course my lasts here would be a +I times a -I. And again, that's just the FOIL. First, outside, insides, and lasts. Now as we simplify, -2 times -2 is 4. Here I have a +2i. Here's a -2i. And at the very end, I have a positive times a -I squared. Well, right away, these cancel, and that makes sense because these are conjugates. -2 plus I, -2 minus I. And I'm just left with 4 minus I squared. But remember, I squared from above on our first page is equal to -1. So in this case, 4 minus a -1 is the same as 4 plus 1. 4 plus 1 is 5. So in this case, I don't have a complex component. I don't need to write 5 plus 0i. I can just go ahead and stick with the 5. You don't need to worry about the 0i component if it's not there. Let's go ahead and look at one other example where we're multiplying complex numbers. And I would remind you, when you see an expression like a quantity squared, a binomial squared, don't think of this as 4 squared plus 9i squared. We actually need to multiply this out. So I have 4 plus 9i times 4 plus 9i. So don't take the cheat and distribute the 2, because remember, that doesn't work. You miss your outside and your inside terms. So you could use the FOIL method here, but you could also use the box method. So I used the FOIL method on the last problem, so this one I'm going to go ahead and use the box method on. Now if you rather use FOIL, we'll end up in the same spot, just a little bit different way of doing things. So I have 4 plus 9i, 4 plus 9i. Now for the box method, 4 times 4 is 16. 4 times 9 is 36, and of course I can't forget the I. 9i times 4 is 36i. Then down here in the bottom right hand corner, 9 times 9 is 81. I times I is I squared. Now we notice here we have some like terms. So when I write this out, I have 16. 36 plus 36 is 72i plus 81i squared. Well, there's that I squared again. I squared is -1. So I should be able to just simplify this. Now the I is just I can't do anything to break that down any further. So here I have 16 plus 72i minus 81. Now again, we're trying to combine like terms here. So I see that I have like terms for my real numbers. So I have 16 minus 81, which would bring us down to a -65 plus 72i as my simplification. So process doesn't change whether you want to use the FOIL method or the box method, doesn't matter. Both of them will work. But what you need to do is to keep track of the i's, the complex component. Okay, let's go ahead and check our answer here using your calculator. This is the 4 plus 9i quantity squared. So you could do 4 plus 9i, and remember that I is above the decimal. And you can either do quantity squared, or you can just write it out again, whichever you're comfortable doing on your calculator. And let's hit enter, and we get -65 plus 72i. So that is the right answer. Let's go ahead and throw that in to our notes. And remember, the decimal point is right below the I, the complex number I on your calculator. So this is a good way to do your work up here and then check your work down here. Now we've looked at adding and subtracting and multiplying. The only thing we haven't looked at yet is division. So let's go ahead and look at dividing complex numbers. Now when you divide complex numbers, the process is really not what you think it would be. You end up actually multiplying by the conjugate to divide complex numbers. So the process here is to multiply by the conjugate. Now remember, we want everything in a plus bi form when we're working these problems. So let's start with a basic problem. Let's look at 40i over 3 plus I. Now, long division isn't not going to work here. You want to think about clearing that denominator, getting rid of the I in the denominator. And the way that we will do that is we will multiply both the top and the bottom by the conjugate of the denominator. So if you wanted to multiply by the conjugate, you could include of the denominator here, because that's what we're trying to clear. Now, conjugate. The conjugate of a plus b is a minus b. So the conjugate of 3 plus I is going to be 3 minus I. And whatever you do to the bottom, you have to do to the top. So the conjugate here, everything stays the same. The only thing that changes is the sign in between the real and the complex part. So in the numerator, we have 40i times 3 minus I. In the denominator, I have that 3 plus I, 3 minus I. So this is the denominator similar to a problem we worked earlier in this lesson. We multiplied by the conjugate, and the outside and the inside terms went away. So all the i's are gone, and you should just be left with a constant. Okay, let's start simplifying this. The 40i will distribute. So in the numerator, I have 40 times 3 is 120i. 40i times a negative I is a negative 40i squared. Okay, now denominator, whether you want to use the box method or whether you want to use the FOIL method, doesn't matter. 3 times 3 is 9. Outsides are negative 3i. Insides are positive 3i. Now my lasts are positive I times a negative I is a negative I squared. So right away I see that I have negative 3i plus 3i cancel. And also, remember, I squared equals negative 1. And I can use that here and here. So let's go ahead and rewrite 120i minus 40 times that negative 1. I squared is negative 1. And in the denominator then I have 9 minus, and then I squared is negative 1. So I have 120i minus a negative is the same as a positive 40. Now in the denominator, minus a negative is the same as a positive, so I end up with 9 plus 1 is 10. Now this is not going to be my answer. I need to simplify this a little bit more, and remember it has to be in a plus bi form. So this is the same as 120i over 10 plus 40 over 10. We need to split this up. Well, 120 divided by 10 is just 12, so this is 12i. 40 divided by 10 is 4. And again, it has to be in a plus bi form, so 4 plus 12i. Remember, it has to be in a plus bi form. So I can't leave this as a fraction. If you want to get credit for it, you actually need to simplify this. Now let's see what our calculators think of this particular problem. 40i over 3 plus I. So we need to be really careful about how we enter this. We need to make sure that we use parentheses to distinguish the numerator from the denominator. So it's important that we have the 40i in the numerator. And remember, the I is second, and then the I is right above the decimal. So 40i, we need parentheses around the denominator, and that was 3 plus I. Okay, so let's see if it will do a division. 4 plus 12i, it's in the a plus bi form. I believe that's what we have for an answer. So let's go ahead and copy and paste that into our notes. Yep, 4 plus 12i form. So it does work. If you ever run into troubles, you will have your handwork to check against your calculator work, You don't want to just depend on your calculator. You want to be able to do these by hand first. Now all of our problems from here on out are going to be kind of tricky. There's going to be something tricky to each of these problems. So I want to work through a few of the harder ones, so by the time you get to your homework, you'll be ready to work on your homework without any troubles. Our next problem that we're going to look at, we're going to be dividing a complex number as well. But for this one, I have a binomial in the numerator, and I also have a binomial in the denominator. So let's remember what the rule is. We multiply by the conjugate of the denominator. So we really want to focus on the conjugate of the denominator. The conjugate of 7 plus 3i is 7 minus 3i. So again, the conjugate, you just change the sign in between. Now, the numerator is the same as the denominator over here, because really, I've multiplied by 1. 7 minus 3i divided by 7 minus 3i is 1. So we're only focusing on the conjugate of the denominator. Now to make this accurate, we really need to have parentheses around the binomials on this side as well. So we need to take this entire binomial times this entire binomial. So let's go ahead and start foiling this out, or you can use the box method as well. 7 times 6 is 42. My outsides would be negative 18i. My insides would be 3i times 7 is 21i. And my lasts would be 3i times a negative 3i, which is a negative 9i squared. Denominator. Now, denominator, I'm multiplying by a conjugate, so I would suspect my outside and inside terms will cancel, but let's check it out. 7 times 7 is 49. Outside, 7 times a negative 3i is a negative 21i. Insides, plus 21i. And then our lasts would be 3i times a negative 3i is a negative 9i squared. Now don't have any temptation to cancel these. You can't cancel terms, you can only cancel factors. But I do see that these negative 21i and positive 21i cancel. And recall that I squared is equal to a negative 1, so I can kind of involve that in this step as well. Negative 18i plus 21i is a positive 3i. Negative 9 times a negative 1, because I squared is that negative 1. So here we have 49 minus 9, I squared is equal to a negative 1. So there's our next step for simplifying. So I have 42 plus 3i. Negative 9 times negative 1 is a positive 9. 49, negative 9 times negative 1 is a positive 9. So let's go ahead and see what we have here. 42 plus 9 would be 51 plus 3i all over 49 plus 9 is 58. Now this is not my answer. I need to put this in a plus bi form. So it needs to be 51 over 58 plus 3 over 58i. So this is the correct a plus bi form. And your answers have to be in the a plus bi form. Let's go ahead and jump to your calculator and see what your calculator does when you have two complex numbers, one in the numerator and one in the denominator. So you have to be very careful about putting your parentheses up, so make sure you start with parentheses. Let's do 6 plus 3i, close parenthesis, divided by 7 plus 3i. Okay, so 6 plus 3i, 7 plus 3i. And hit enter. Okay, so this does not look anything like my answer. I had like 51 over 58 plus 3 over 58, and that doesn't look like that. It's in decimal form, so let's cross our fingers and hope that math frac will work. So over here, math, choose 1 or enter for frac. Enter to execute. Here we are. Here's our complex form. 51 over 58 plus 3 over 58i. So that is the correct answer. So for here, we just need to remember to convert it back to a fraction. Again, it's always better to do your work by hand and with the calculator to check it, just in case you make a mistake with your calculator or your handwork, you'll be able to catch it. Okay, so multiplying, or sorry, this one was dividing, yes. 6 plus 3i, you need to make sure everything is in parentheses, divided by the entire denominator must be in parentheses as well. Okay, for the rest of the lesson, we're just going to kind of work through some various problems. Some will be multiplication, some division, some simplifying, but that a plus bi, or that standard form, will be a common theme throughout. Okay, let's go ahead and look at something that we haven't quite seen before. It's kind of something new. For this problem, we're being asked to simplify and rewrite this in standard a plus bi form. Well, -9, before we couldn't take the square root of a negative number, but now we have complex numbers. So when I'm talking about the square root of a -9, square root of 9 is 3, square root of -1 is I. So the square root of -9 is just 3i. Similarly, square root of 64 is 8, square root of -1 is I. So 4 times 3 is 12i, 8 times 3 is 24i, 12 plus 24 is 36i. So some of these that you run across are going to be pretty straightforward. Now let's grab your calculator on this one as well, just to see what happens. So let's do 4, and then our square root key is right above the squared key. So 4 square root. We don't want to use the minus key, we want to use the -9 here. So 4 times the square root of -9. Okay, plus 3 times the square root, so that's second square root, -64. And let's hit enter. Now your output might look a little different. You might have a little square root sign in a parenthesis, and you need to just make sure that you fill in your value and close the parenthesis. Calculator doesn't know what to do with this problem because it doesn't understand what a square root of -9 is, so it can't work the problem. So that's why it's going to be important that you be able to work these by hand as well. So the calculator doesn't really help here. Now if you recognize that this was 3i, you could put in 4 times 3i using your second I key, plus 3 times 8i, I believe we had. And then it can deal with it. You have to put it in I first. Otherwise, it does not know what to do. It's kind of stuck. So for these types of problems, you kind of have to help your calculator out just a little bit. You have to simplify it before you input it into the calculator. So that's another type of problem that you'll run across in your homework sets. Another type of problem that you'll run across is simplifying. So you'll be asked to substitute a complex number into an equation and solve. So for instance, you might have something like evaluate x squared plus 12 all over 1 minus 2x for x equal to I. Something like that. So that means basically everywhere that you see an x, you're going to plug in a 2i. So here we have x squared, x is 2i, 1 minus 2x, x is 2i, so I plug it in here, and I simplify. So 2i times 2i, 2 times 2 is 4, so I have 4i squared plus 12. And in the denominator, I have 2 times 2 is 4i, it's a minus sign, so I have 1 minus 4i. Shoot! We're going to end up having to multiply by the conjugate here, but before we worry about that, this I squared is equal to a -1. So I have 4 times -1 plus 12 all over 1 minus 4i. So -4 plus 12 is 8 over 1 minus 4i. And of course we can't leave our answer like this because I don't want an I in the denominator. I need to take that 8, 1 minus 4i, and I need to multiply this by the conjugate of the denominator. Now the conjugate of 1 minus 4i is 1 plus 4i. 1 plus 4i. And then you're going to run through the problem the same as you did before. The 8 distributes, and then in the bottom I'll FOIL. 8 times 1 is 8. 8 times 4 is 32i. And then in the denominator, when I FOIL this out, my outside and inside terms should cancel. 1 times 1 is 1. Negative 4i is my inside. My outside is plus 4i. And my lasts would be a negative 16i squared. So in my numerator, 8 plus 32i. Now in my denominator, my outside and my inside terms cancel. And then again, I have to remember that I squared is equal to negative 1. So again, I squared equals negative 1. So 8 plus 32i all over. Negative times a negative is a positive. 1 plus 16 is 17, but that's not my answer. I need to put it in a plus bi form. So I'll have 8 17ths plus 32 17ths I. There's my solution. So this one turned out to be a little bit longer, not just substituting, but also having to simplify. Now, if you were to put this into your calculator, you wouldn't put it in up here at this point. You would put it in down here at this point. So this is where you would start with your calculator entry. So let's see if we can remember this one. 2i quantity squared plus 12. So let's come over here. I need to open up my parentheses and an extra set for the 2i. So 2i quantity squared. Now you might just end up with a caret key here instead of the going up into the exponent, and if you just have a caret key, that's fine. So 2i squared, let's see, plus 12. Oops, my plus sign didn't get in there. Close parenthesis, divided by, and we're dividing by 1 minus 4i. And I can just put in the 4i if I want. And if you wanted to put in the 2 times the 2i, you can. And that's my entire denominator. And again, I'm going to get the ugly fractions, and let's cross our fingers that this will be able to convert this to fractions to check our answer. And it did. So let's go ahead and double check our work here and see. And let's say 8 17ths. These always come in way too big. So 8 17ths plus 32 17ths I, so it is correct right here. And I'm not sure what the kind of the shadow work is behind it. Might have been our problem from before, but hopefully you can see that pretty clear. So you're going to run into a lot of different problems, a lot of different simplifications. The next problem we're going to look at is kind of one of the tougher ones. It's a layered fraction. So this one isn't very difficult after we deal with the layered fraction, but if you don't deal with the layered fraction correctly, this might give you some trouble. So let's go ahead and start with 3 over 3 plus 4 over I. So you can see that we have a numerator and a denominator, but within the denominator we have another numerator and denominator. So before I can work this problem, I need to find a common denominator in the overall denominator. So that's kind of my strategy here. So lots of simplification for this one. So I have 3 over 3 plus 4 over I. Well, right now this denominator under the 3 is a 1, but I want to find a common denominator between 1 and I, and the common denominator between 1 and I is I. So I'll multiply both the top and the bottom here by I. So I have 3, and then I have 3i plus 4. And now since this is a common denominator, I can rewrite that under one denominator. Now, the rule is when you divide by a fraction, you multiply by the reciprocal. So this is going to be 3 divided by 3i plus 4 over I. And again, the rule is, and if I want to write this as 3 over 1, I can. When you divide by a fraction, you multiply by the reciprocal. So this reciprocates and the I comes up top, and the 3i plus 4 drops down. So then multiplying straight across, I just have 3i over 3i plus 4. So we've done the hard work. Now we have to simplify this, and of course to simplify this we need to multiply it by the conjugate. The conjugate of 3i plus 4 is 3i minus 4. So from here, the 3i distributes. 3i times 3i is 9i squared minus 12i. And we're back to familiar territory here. Now the denominator, 3i times 3i is 9i squared, and do not be tempted to cancel these. They're not factors, they're only terms. And then what will happen is my outside is a negative 12i, my inside is a positive 12i, and my lasts would be a minus 16 then. Now what happens when you multiply by a conjugate is things cancel, and that's what's happening here. And then of course we want to remember I squared is equal to a negative 1. So here we have a couple of negative 1's that we can plug in there. So again, I squared is equal to a negative 1, I squared is equal to a negative 1. So the numerator I have a negative 9 minus 12i. And the denominator I'm going to have a negative 9 minus 16, which is a negative 25. Now this is not my answer because it has to be an a plus bi form. So I have a negative 9 over a negative 25, negative 12 over a negative 25i. This is not my final answer either because a negative divided by a negative is a positive 9/25. Negative divided by a negative is a positive 12/25 I. This is my solution. Now 9 over 25, they don't have any common factors to reduce. 12 over 25, no common factors to reduce either. So next, let's go ahead and check this with our calculator. Now the tricky part for this one will be getting it into your calculator correctly. So let's put the numerator in parentheses, 3 over. Let's put the denominator in the parentheses as well, 3 plus 4 divided by I. Now I is, remember, the second above the decimal, close parenthesis. Now I'm thinking we're going to get some ugly decimals here. No, they're not too bad, 0.36 and 0.48. And we can convert them, math, frac is our first option, so either hit 1 or enter, and then execute the command. And I believe this matches with what we had for our solution. So again, you can double check your work with your calculator. Always do it by hand and check it with your calculator though, just to be sure that you don't have any mistakes on your calculator, because we could put this in incorrectly. We might have a parenthesis in a wrong place, and then I'd have it counted wrong. And so that's why it's good to do the handwork as well, so you don't get something really simple counted incorrect. Okay, I know we're running up against 40 minutes here, but I want to throw in a couple extra problems for you, so if you're interested in sticking around and watching, these might help you out with your homework. Let's look at negative 7 minus the square root of a negative 6 quantity squared. What we want to do with this one is we want to rewrite this in terms of I first. So the square root of 6, I can't simplify, it's just the square root of 6, but the negative I can pull out. Now notice that this negative sign is not underneath the radical. This I is outside of the radical. Now sometimes you'll see this written as I root 6 as well. So sometimes again you'll see this written as I root 6. And either way it doesn't matter whether the I is out front or back. The point is it's not under the radical. And then from here I can FOIL this out or use the box method. Negative 7 times negative 7 is 49. My outside would be a negative times a negative, which would be a positive 7 square roots of 6i. My insides would be a negative times a negative, which would be a positive 7 square roots of 6i. And again, be careful, this I is not under that radical. And then a negative times a negative would be a positive root 6 I times I. And of course we can simplify this. 49 plus, now here I have a 7 root 6i, 7 root 6i, so these are like terms. I can combine these. Well, 7 plus 7 is 14. And just for clarification, I want to make sure that I is not under the radical. I'm going to pull it out front, and remember you can see it written either way. And then over here, And then we have the square root of 6 times the square root of 6, which is 6. But if you're not sure about that, you can think about it as the square root of 36. And of course, in our next step, we would know that the square root of 36 then is just 6. Now again, I squared is equal to a negative 1. So we can plug that in here. So I have 49 minus 6 is 43 plus 14i square roots of 6. So here's our solution. Now, unfortunately, you're not going to be able to really check this one with your calculator because your calculator does not simplify it like something like a radical 6. You could compare it as a decimal. So you could take 14 times the square root of 6 and then compare it with your decimal solution that you get. One other one that we could work on our way out the door here, we could look at the square root of a negative 12 times the square root of a negative 5 minus the square root of 7. So we have a lot going on with this problem because I have some negatives under the radicals and some not, and then I also see that I need to distribute. So we need to be careful about our steps here. This one is I root 12. This one is I root 5. And of course this is just minus square root of 7. If you take 12 times 5, or a negative 12 times negative 5 and get 60, notice your I squareds go away. So you have to simplify these first before you distribute. So let's go ahead and distribute these now. And if you wanted to, you could also simplify the square root of 12 first. So when I distribute, I get I times I is I squared, root 12, root 5, minus I, root 12, root 7. And then we just start simplifying. So we know I squared is negative 1. The square root of 12 is the square root of 4 times the square root of 3. Square root of 5 we can't really do anything with to simplify. And just as before, the square root of 12 is square root of 4, square root of 3. And the square root of 7 can't do anything, so we drag that along. So here we have negative 1. Square root of 4 is 2. Now, root 3 and root 5, I can't simplify them at all, so I can recombine them underneath the radical for root 15. And then over here, I have minus square root of 4 is 2. And then root 3, root 7 can't simplify either, so I have root 21. So let's go ahead and rewrite this then. I have minus 2 square roots of 15. And then over here I have minus 2i square root of 21. Now again, on this one, you can't check this really on your calculator either unless you go for decimal approximations, because your calculator will not simplify radicals for you. So we've gone through a large cross-section of problems. We've looked at some of the harder ones toward the end here, so hopefully when you hit your homework, you should be able to get a pretty good start on it. If you have any questions, please let me know.